Hello, welcome back. My name is Mr. A. Today, we're going to talk about factors and multiples. There is basically just one word that separates these two amounts. And that word is that factors are values that can be divided from an original number or value, whereas a multiple can be multiplied from an original number or value. There are another little difference that you can find between them is a factor will always be equal to or less than an original value. Whereas the multiple has the opposite effect. This is always going to be equal to or greater than its original. That's the difference between a factor and a multiple. The examples we're going to go with, for the factor side, we're going to find all the factors of 12, 20, and 25. For multiples, a little bit different. We're only going to find the first few multiples of 5, 7, and 12. The reason we are only going to find the first few multiples is that multiples are infinite. They will go on and on and on and on if we let them. So for multiples, you are never going to be asked to find the greatest multiple because there is no greatest multiple. It's going to keep going and going and going and going, and there's just not enough time in the world to reach the greatest common multiple. Factors, on the other hand, are pretty limited. For factors, we need to find all the values that can be divided from 12, 20, and 25. So starting with 12, what's something that we can divide everything by no matter what? 1. We can divide 12 by 1. And an easy way that you can find more factors is do that division. 12 divided by 1 is going to give us 12. And we've already found 2 factors of 12. Another set, since that's an even number, we can divide all even numbers by 2. And then we think, all right, what is 12 divided by 2? That's going to be 6. So we'll include 6 in that. Then we look a little harder and we start thinking, what else could we possibly do? We've tried 1, we've tried 2, what about 3? Give 3 a shot. 12 divided by 3. Is that something that can work? Yes. 12 divided by 3 does work. So 12 divided by 3 is going to give us a value of 4. Then you start thinking, okay, so we got 1, 2, we got 3, we got 4. Is 5 going to work? No, that's not going to work. 6, we already have it. 7, no. 8, no. And you start thinking a little harder and you realize, nope, this is it. These are all of the factors of 12. We can't go any farther. We apply the same process to 20 and 25. If you want, go ahead and pause the video now so that way you can try to work those two out on your own. But otherwise, I'm going to keep going. For 20, once again, we can divide it by 1. And that's going to give me an answer of 20. Then I think, all right, that's an even number. Let's divide by 2. 20 divided by 2, that's going to give me 10. Think a little harder. 3, no, that's not going to work. 4 is going to work though. So I can divide 20 by 4. That's going to give me 5. And I think, okay, 20 and 6, no. 27, no. 20 and 8, no. Nothing else is going to seem to work. So that's it for 20. And you notice, even though we went from a number like 12 to 20, we almost doubled our value, we didn't double the number of factors. You're not always going to have more factors with a larger number. Case in point, for 25, we run into a special kind of problem. 25 is an odd number. That doesn't mean that it doesn't have factors, it just means you're going to have to approach it a little differently. You're still going to have to do divided by 1 and 25 divided by 1, we get 25. But there is only one other factor. Well, it's not going to be 2 for sure, that's an odd number. 3, no, 3 might have gotten it if it was 24, but no, not this time. 4 isn't going to work either. But because it ends in a 5 or a 0, we can divide it by 5. So 25 divided by 5 gives me 5. This is a special kind of number. This number would be called a square number. And that just means that it has 3 factors and only 3 factors. 1 itself, and then one other number. In this case, it would be 5. But we'll talk about square numbers another time. For now, multiples. For the multiples, let's just go with the first, how about 10? First 10? So just the first 10 for 5. You'll find this one to be kind of easy. So the first 10 multiples of 5 will be 5, because that's 5 times 1. Then we do 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. I suppose this is a good time to point out a little shortcut you can take. Instead of actually saying 5 times 4, 5 times 5, you can just count by 5s and you'll have the same effect. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And unlike our factors, in which we put a period at the end, because factors do not continue, multiples will technically go on forever. So instead of putting just a period, I'm going to put ... to indicate that it doesn't just stop at 50, it's going to keep going, we just don't have the time or resources to continue listing them. Moving right along for 7, we'll do the same thing. We can count by 7s, and I'm going to try to use a double line because I had to write kind of smaller there. So for 7, we have 7, 14, 21, 28, 35, 42, 49. I'm going to move to the next row. 56, 63, 70, ... because it's going to continue. For 12, we're going to do the same process once again. For 12, we have 12, 24, 36, 48, 60, 72, 84, 96. Had a temporary moment where I forgot how numbers work. This is embarrassing. 108. Oof. And 120. ... These are how multiples and factors work. This ought to be a good start to get you caught up for what you would have missed if we went over factors and multiples. Thanks for watching.